So why do atoms bond? Atoms bond to get a full outer shell. They want a noble gas configuration. Noble gases have a full outer shell. That's why they don't react. Things react, atoms react to get a full outer shell, to get a noble gas configuration. So here we've got the noble gases in group 0 or group 8. So we've got helium, neon, argon, krypton, xenon and radon. And basically all the atoms that do react, they react to get a full outer shell just to be like one of these noble gases. So you can see helium with only one shell or one energy level only needs just the 2 electrons in that first shell because it's in period 1. In period 2, neon has got 2 shells, so therefore it needs 8 in the second. So using the 288 rule and the idea that the number of shells is related to the period number and the number of outer electrons is related to the group number, we can move through. Now the first type of bonding we're going to look at is ionic bonding. Ionic bonding involves producing ions. Ions are just atoms that have either gained or lost electrons to form a charged particle. So if we look at metals on the left hand side, so I write it like that, it's like a positive sign instead of a T, so it looks like metals, but it just reminds you that metals form positive ions. They do that by losing electrons. So if we look here at lithium, lithium is atomic number 3. We can highlight it down the bottom here. It's got atomic number 3, so therefore 3 positive protons, 3 negative electrons. Those negative electrons are put in the shells, 2 in the first, 1 in the second. It wants to be like helium. So how does lithium get to be like helium? It will lose 1 electron, so it goes from 2, 1 to 2. Over the other side, we've got non-metals. Non-metals is hyphenated. But we can use that hyphen as a reminder that they form negative ions. So we're dealing with opposites here, positive and negative. So the non-metals form negative ions because they will gain electrons. So if we look at fluorine here as an example with a proton number of 9, so atomic number 9, 9 protons, 9 negative electrons. So down here, those 9 electrons go into the shells, 2 in the first, 7 in the second. So how does fluorine get to be like its nearest noble gas? Well, the nearest noble gas is neon. It's going to go from 2,7 to 2,8, so that's going to gain an electron. So basically the number of electrons either gained or lost will determine the value of the charge. So a metal will lose electrons. If they lose 1, it's 1 plus 2, 2 plus 3 electrons lost, it's 3 plus. Over the other side, it's the same deal. So oxygen would form a 2 minus ion because it needs to gain 2 electrons to get up to 2,8. There we go. So when we're looking at ionic bonding, all we need to think about is metals will lose electrons. So again, sticking with lithium, to go from 2,1 to 2, and fluorine here will go from 2,7 to 2,8. So the metals are going to lose, the non-metals are going to gain. So we only deal with the outer electrons because basically it's the outer electrons that get involved in bonding. So when these particles collide, it's the outer electrons, the ones on the outside, that are going to interact. And for ionic bonding, the metal will lose, the non-metal will gain. So when this happens, they form ions. Why are they ions? Because basically, as an atom, we've got equal numbers of protons and electrons. As an ion, they're not equal. So the positive charge for lithium, for the metal, comes from the fact it's got 1 more positive proton than it has electrons. It's lost 1 electron. If we go over the other side and we look at fluorine as an atom, again, it's neutral, 9 positive protons, 9 negative electrons. But when it gains that extra electron from lithium in this case, it has 1 more electron than it does protons. So 9 protons, but 10 electrons. It's 10 electrons to fill up that second shell to make it have 8. So when that happens, that becomes negative. So what we have here is a positive and negative species, and what do we know? Positives and negatives attract, opposites attract. So you have then this electrostatic forces of attraction, or forces of attraction. That is the ionic bond. That is what holds the lithium and the fluoride ions together. we look at covalent bonding, covalent literally means sharing valence electrons. Valence electrons is another name for outer shell. It's always the outer shell electrons that we're dealing with. So covalents, they share. Why do they share? Because we've got two non-metals. The non-metals want to gain electrons, but if we've got two non-metals and they both want to gain, neither will give up an electron to the other. So what they end up doing is sharing. So when we see, like here we can see that line, that bond that is used to represent the covalent bond. What you will be asked to do in an exam is to complete a dot and cross diagram. So basically, anytime you see a line like that, or they ask you to think about having a bond between two nonmetals, it's a covalent bond, you should draw a dot and cross. Just like a Venn diagram in maths, if you draw a dot and cross in an overlap, you can count the electrons in both shells. So here, hydrogen has got 1, 2 electrons, because it's within the hydrogen outer shell, but they're also counted in the fluorine outer electron. So we've got for fluorine 2, 4, 6 and then 8. And then again, the electrostatic forces of attraction are coming from the fact that we've still got obviously positive protons in the nucleus of each atom, but they're being attracted to the overlapping electrons. So again, electrostatic force of attraction between the positive nucleus of each atom and the overlapping electrons. Here's just a few examples, typical examples that they use. So they like to use methane. So we've got central carbon atom, 1, 2, 3 covalent bonds. So central carbon atom, 1, 2, 3 overlapping sort of shells with 1, 2, 3, 4 dot and crosses in it. The dot and crosses are just used to track or trace where the electrons have come from. So in this case, because the carbon has got crosses, then the crosses in the overlap come from the carbon. This is ammonia. This is another typical example. So 1, 2, 3. So we have 1, 2, 3 overlaps. So 1, 2, 3 dot and crosses. The really important thing to remember is that when these atoms bond, they're doing it to get a full outer shell. So if you're drawing an ionic species, sort of like an ion, or you're drawing the dot and cross diagrams for covalent compounds, you just need to make sure that they've got a full outer shell. So hydrogen, each hydrogen is exactly the same, so you only need to count one. That's got 2 in its outer shell, and then nitrogen has got 8 in its outer shell, so that's complete. Same deal with iodine. Just because we've got 2 atoms that are the same, it doesn't make any difference. We've got 2 iodine atoms. They will form the I2 species, so that's an iodine covalently bonded to another iodine atom. So here it's just the same, dot and cross, count them up, 1 overlap, 1 dot and cross, because we've only got 1 covalent bond. The reason we've got 1 covalent bond is that iodine is in group 7. It needs to get 1 more electron in to get it up to 8. So every covalent bond adds an electron. So if it only needs 1, it's only 1 covalent bond. The final type of bonding is metallic bonding. So again, we'll go back to lithium. Lithium, again, looking at that as an atom, 3 and 3, so 3 protons, 3 electrons. They're neutral overall because the number of positive protons and negative electrons are balanced. Metals lose electrons when they bond, so lithium will lose an electron. So each lithium atom will lose an electron and it becomes delocalized, which means it can flit about the structure. So the bonding in metals is just a series of regular layers of positive ions that are attracted to the delocalized electrons. So again, it's just electrostatic forces of attraction. I've tried to show it here with an electron between 3 positive ions, and they're all being attracted to the positive nucleus of each ion. So nice and straightforward. So the notes that we are going to think about, okay, they're either going to share, lose or gain electrons. So metals lose and they form positive ions. Non-metals are the opposite. Non-metals gain and they form negative ions. So we're dealing with opposites here. It makes it nice and simple. Metallic structures are fairly straightforward. And Okay, the only thing you need to do is if you're ever drawing out, say like an ion, and it's positive or negative, just double check that the outer shell has got, in this case, 8 outer electrons. Make sure it's full, because that's what you're doing. And then also, if you're drawing out covalent bonds, whatever it is, if there's one covalent bond, just make sure that we've got a full outer shell. If it's in group, if it's in period 2, 3, 4, whatever, it's going to have 8 in its outer shell. The only one that you need to watch out for is hydrogen, and they use hydrogen a lot. But hydrogen, because it's in period 1, it only needs one dot and cross to complete its outer shell. Good luck.